Hello everyone and welcome to another video presentation courtesy of the University of North Texas Physics Department with the assistance of the Physics Demo Room. Today we're going to be talking about is pressure. So pressure is defined as the amount of force per unit area an object feels. Now every single day we experience the pressure from the air that surrounds us. We don't really notice it that much because we've grown up with this feeling all of our lives. But if we look at how different areas and how different forces can affect things, we can then apply it to everyday life. So maybe some things that people have noticed in the past is, for example, if the ground has been wetted because of rain, and anyone that walks with a prominent heel, it is a very, very, very small area. But it's sometimes when you're stepping onto it, all of a sudden that heel will sink into the ground and that heel will be stuck. Whereas another person might be walking with steel-toed boots and they won't sink in at all. Now, some of you might say, well, that has to deal with the weight and not the shoe. In reality, that's actually half the case. Half of it has to deal with the weight or the force that the mass of that person has by the effect of gravity, along with the area at which you are distributing that weight on the ground. For those of you that did not grow up in the northern states that have to deal with ice and with going on lakes a bunch, or dealing with freshly covered snow, this is why snowshoes usually have a larger surface area than the typical shoe that most people will use to help them go on top of the snow instead of trudging through it. So a concept of how to see different objects with different pressure, sometimes denoted as PSI or pounds per square inch. I know this is not the standard unit that is used for the System International, but it's related to most of you dealing with tire pressure. It's the amount of force that the area is having per square inch inside your car. So what we have is we have this little diagram right here which talks about pressure. Now, as you can see here, we have a diagram of a woman wearing a prominent heel shoe, to where you can see that the pressure of a 100-pound woman has to do with 12.7 square inch foot with basically a 16 square inch heel. We have a PSI about 3.9, and we also have a PSI of 313 for two heels. So for the feet, it's only 3, but the heels, it's 13. Oh, it's not 10.6, it's 0.16, my correction. But now if we look at an elephant's foot, at all this surface area, it's a 4,000-pound elephant with 43.5 square inch foot gives us 23 PSI. So that means the pound per square inch is less here than it is for the heel of two heels by a 100-pound woman, even though the elephant is 4,000 pounds. And now we go over to the square inch foot for a 200-pound male is 36.2 inches, but a PSI of 2.8 per square feet. So this is where we can see between this, because the area is flattened out overall, we see that the PSI is relatively small. But now, when you talk about just the feet part, we have a low PSI, but when you go down this heel, the PSI now dramatically increases. So that means that the pressure and the force that it's going to be experienced over that little area is going to be greater. So now a lot of you might be saying, well, Corey, how do we see this in everyday life? Well, some of you might say, I have this nail right here on this little block of wood. And with this nail, what I can see is that, if I was just to hit this on the ground, not do too much to it, this will puncture through a lot of different things. So this nail is just on a block. So if I was to rest all my body weight on this nail, it'd probably go right through me, because the surface area right here is very small. So it's going to puncture, because the human body medically has proven that for, let's say, a scalpel, you only need a certain amount of force to penetrate the skin. So now, with that concept of the amount of area being exposed can reduce the impact on someone, we are now going to look at, well, what if I have, instead of one nail, I have thousands of nails or hundreds of nails? Can I sit on here and not be punctured or not have it to where I'm going to get stuck? So that's where, with this point of the trial, is going to be very interesting to make sure that, hey, I'm not going to get stuck. Now my pants, I'm going to sit on this little piece of wood. Now my pants aren't exactly rugged in terms of, let's say, jean-like material. It's more of a polyester blend. So what I'm going to do to just help with this a little bit is I'm going to put this little piece of cloth and just put it on top of it. It's not going to do any video editing, just kind of help me save my pants a little bit, and then I'll do it again without them. That way we can make sure about the comparison of the differences. So the biggest thing that's dangerous about covering these nails is that when I'm going to be sitting down, I don't want to put all my weight on my hands and sit on these and put my weight on my hands and push down, because then I'm going to put all my weight on my hands and go through the nails. It's not really fun to do. So what I'm going to do now is, very interestingly, I'm going to get up on the table and I'm going to take a seat. And I fall. Okay. So now I'm going to get in front of here. Not too bad at all, I would say. So now what we're going to do is I'm going to take off. That way you see there's no trick. Now I'm sitting on a seat of nails. No blood, no pain, nothing. No issue at all. So, as I come back around, and we can verify that at least didn't rip through my pants. Don't see anything there. See no blood on the seat of nails. So this is where pressure comes into a big consideration. Now, one thing we could have done, which I don't have a helper here, is I could have been laying on a bed of nails, had a giant chunk of ice on top of me, and someone break that chunk of ice, and I won't go through, because the force is going to be evenly distributed throughout the whole seat of nails, because the surface area has increased drastically compared to just one nail where that surface area is very, very small. So thank you for watching this video presentation, and have a wonderful day.